Quantum state teleported by entanglement. Antimatter forming wave patterns. You're watching today's Global Tech Pulse. Across air, a quantum state is no longer carried from one place to another. It is recreated at the destination. Scientists have transferred a photon's quantum information 270 meters between two completely independent systems. Earlier, this worked inside tightly controlled labs, where both systems shared timing and environment. Outside, even slight disturbances would break the process. Now, the system behaves differently. At the core is entanglement, where two particles form a single connected state. They don't act independently anymore. Defining one immediately defines the other, regardless of distance. When a photon carrying information meets this system, a Bell state measurement is performed, a process that forces the incoming photon and one part of the entangled pair to combine into a shared quantum state. This step is critical because it transfers photon's information into the entangled system itself. As this interaction completes, the original state at the source no longer exists, and the distant particle settles into that exact same state. So the information is not traveling through space, the system itself updates, and the state appears at the destination. What changed is fundamental. Communication is no longer about sending signals but about synchronizing states. This enables quantum key distribution, where any attempt to observe the data breaks the state itself, making interception physically impossible. And when information behaves this way, matter begins to reveal the same underlying rule. Antimatter now shows wave behavior. Scientists have observed antimatter forming interference patterns, the signature of a wave spreading and overlapping with itself. Earlier, this wave nature, wave particle duality, was confirmed only for normal matter. Antimatter was too unstable. It annihilates instantly on contact, making observations extremely difficult. Now, by slowing down particles and isolating them in near perfect vacuum, the motion becomes measurable. As an antimatter particle passes through extremely narrow slates, it does not move along a single path. It spreads as a probability wave across both paths at once. As these overlapping path meets, they reinforce and cancel in patterns, forming clear interference fringes. This reveals its de Broglie wavelength, showing that even antimatter follows the same wave-based description as ordinary matter. What changed is deeper than expected. The same quantum rule applies even to the most unstable forms of matter. From information that no longer travels to matter that no longer behaves like a fixed object. We are not just advancing technology, we are uncovering the operating principles of reality itself. That's today's Global Tech Pulse. If any of these interest you, I can break them down in detail. Just let me know the topic in the comments. Follow for daily tech news. Nandri, Vanakkam.